Hi everyone, hope you're having a great day today at the Future Formulations. My name is Ioanna Danai. I will be introducing to you my poster on measuring the specific surface area of inhalation-grade lactose powders. Specific surface area is a very important metric, especially on inhaled powder formulations, as it has been associated with monitoring the changes in their performance. It can be affected by the particle size distribution, the porosity, and the surface roughness, and is typically measured by gas adsorption techniques, where we would be increasing the presence of vapor probe molecules of gases on the surface of these powders. And once we are happy with the gas adsorption type, whether it is a type 2 or type 4, then we can apply the BET theory. Typically, we would be using nitrogen or krypton. However, these are quite expensive, especially krypton, and they are performed at well below 0 temperatures, risking crystal fracture, crystal damage. And it can be tricky to get values for particles that exhibit low SSA values. So recently there is work being done on the use of inverse gas chromatography and dynamic vapor absorption to calculate the SSA, but we wanted to check whether we can apply an imaging technique to measure the SSA of materials that have low values. The powders that we have used are different grade inhalation powders: alpha lactose monohydrate, sieved, milled, and milled with removed fines. And the techniques that we've used are inverse gas chromatography based on octane adsorption, nitrogen adsorption, which is the standard, and X-ray computed tomography. This is just to show you that as we can see from the SCM, we have coarse carriers and then smaller particle size. I am aware that my face hides the results over here, but you will be able to see that with more detail on the poster. These are the results that we get from the XCT. So it's a 3D reconstruction of a powder in a set volume. In brief, the results are that both of the techniques were able to distinguish between the different grades. There was quite a good agreement between the IGC and the nitrogen adsorption, although I said it's hard to get a direct comparison between the techniques. For the milled materials, things are getting a bit trickier when we go into the sieved lactohale 100, where we get a very poor linear regression coefficient from the nitrogen adsorption. Interestingly, when we are seeing the result from XCT, we actually get an SSA value that is sitting in between, so it's in good agreement with the rest of the techniques. However, we cannot, due to the resolution of the image, account for the surface roughness of the powders. And with this, I'm going to leave the rest of the poster to you, and I will be here for the day answering questions if you're interested. Thank you for your time.